juggle too many things, so I'm hosting and moderating. Okay. Okay, we're good to go. So, thanks everyone for coming. Yeah, obviously you know already this is a discussion on graph databases, and really happy to have with me, well, 3 of the most knowledgeable people around on this topic, and hopefully this is going to be interesting. So, in no particular order, here we have Stephen Sarfield from Cambridge Semantics, who's the VP of Product and also sponsoring this panel. So thanks, Steve, and thanks, Cambridge Semantics. On the other side, we have Joshua Schnaver from Uber, whose keynote you probably saw already this morning. So I guess you know already a few things about him and what he works on. Well, Apache Tinkerpop is one of the key frameworks in this space. So glad to have you with us, Josh. And last but not least, Jeff Horrell, who's like returning guest to this panel from last year as well. Hope we do better this year. And Jeff has been tinkering with a number of different graph databases, so well, he knows a few things about them. And actually, he was the one who kind of suggested the first question to tackle, which is actually why graph? I mean, why using a graph database in the first place? So that was a kind of provocative way of framing it that he used. So couldn't you just do some of the things that you do with graph databases in, I don't know, other ways? So your question, you are the first to get to answer that.
I knew I should have just kept to the questions that you suggested, George, shouldn't I? So yeah, Jeff Horrell and I run our Refinitiv labs in London, and we have a team of data scientists and engineers trying to solve different business problems. So we get to test and experiment with a lot of things. I mean, at Refinitiv, we use graphs, we use RDF to model our metadata that underpins kind of our all of the content that we manage as Refinitiv. We also published our data and metadata as RDF out to the market. And I guess we've got some good experience trying to sell graph-enabled data out to the financial industry. And I think from that, what are graphs good for, what are they not good for? Often what we see customers is they come to with a problem where they say, I want to improve the way I'm tagging and managing my documents, and I think I need to use a lot of metadata to do that. And so we'll say, right, well, you should use NLP, and you should mark up your documents, you should create that metadata, and you should structure that as a graph. Because it makes sense, and it's intuitive, and you can then do some semantic things with it. But actually, often what they also need document management. They need an Elasticsearch database. They need to have ways to connect other structured, traditional tabular data alongside that. And actually what often happens is that the graph element is actually quite a small piece. It may be the critical piece of the puzzle, but it's actually quite a small piece of the puzzle in terms of the overall types of data they're managing and other types of infrastructure that they're managing. And so I think what we've seen is that we think graphs are great for lots of things. When we go and sit with our customers, often graph is just like it's one piece of the puzzle.
Sure. So why graphs? Well, you kind of heard my take on this morning. Some of us who came to graph databases in the early days came to it from the point of view that we think in graphs before there was any kind of real business in it. It just seems that graph schemas, the graphs are a natural way of expressing the way we naturally conceptualize things, and that's a hard thing to talk about. It's a hard thing to really say exactly what we mean by that. Since we don't really have a good agreed upon model of mental representation, so that's what I kind of tried to tease out this morning. There are a few ways of thinking about that. But yeah, I think that graphs have the advantage over, say, relational databases, that people just have that aha moment, that it naturally captures how they were already thinking about their data. On the other hand, when you say graph database, I don't think there's necessarily, and a couple of the other speakers touched on this today as well, a graph application does not necessarily imply a graph databases. More and more we're starting to build virtual graphs that have data in some original source data format, relational, key value, whatever the case may be, and then we build graph abstractions on top of it. And it's often actually inefficient and a waste of resources to ETL data into a graph database if you already have the graph in some other format. So we need to find smarter ways of defining mappings and federating data sets, and we're starting to see a lot more of that these days.
Yeah, hi everyone, Steve Sarsfield. I work for AnsoGraph, or Cambridge Semantics, which is the maker of AnsoGraph. Why graph? It really starts with the graph algorithms themselves, right? I think that's why people come and look at graph. They're trying to do a page rank, or they're trying to do shortest path, and they look and they try to do it in their relational database. It may involve moving data around. It may involve a really expensive join. It may involve a lot of things that are very expensive to do in a relational database. Then they may try to do it in Spark. Spark is sort of a stack of products where I might need Spark and Hadoop and HDFS and Zookeeper and a bunch of other stacks, things in the stack in order to accomplish that. And so, that could be time consuming. There's a lot of knobs to turn. It may be pretty difficult to achieve that in Hadoop and some of the open stacks. So they come to a graph database, and the interesting part of it is when you do your page rank in a graph database, it is really fast, and it does really execute well. But you can also do your BI style analytics in a graph. And you can do selects, and you can do averages, and you can do counts, and all the things that you're ready to do in your relational database, you can also do in your graph database. So there's two parts of it. It's graph, which are the graph algorithms, and database, which allow you to do normal analytics as well. So that's what's the power of graph to me.
Okay, thanks. So we already kind of touched upon the issue of, modeling and representing graph data, and we already have, kind of two camps, if you want to call it that there. So you have RDF and labeled property graph. Josh already mentioned a few things about that in his talk in the morning. And the interesting thing that has come up relatively lately is that we also have a kind of bridge proposal, let's say. It's called RDF star. And it's a way of, enabling RDF to model property graphs, basically. So the next question that I'm going to tackle is, what's your take on that, basically? So where do you see, do you think it's a good idea? Do you think, it has any flaws or anything missing, anything that should be added?
In the interest of time, we decided I wasn't going to answer this question.
We'll go to Jeff.
I thought I got to skip this one too, So I don't know much about this at all. Apart that, the challenge that I see is the adoption, right, of RDF. I think it's really powerful. We really use it a lot in Refinitiv, but it's hard sometimes to get people who are used to seeing the nice kind of glossy pages of the property graph companies. Like, this looks so much simpler and easier to understand. And I think anything that helps RDF to be more widely adopted in the developer community, in the rest of is a good thing. Anything that makes it easier and more powerful to represent those business concepts is a good thing. I think the challenge is trying to get and grow adoption. There's other ways to do it apart from RDF star, but it's certainly something that I think is an interesting development. But that's all I have to say on that.
Well, I happen to love this topic. This is a great topic because RDF star is here. We have AnsoGraph, we have Blaze Graph, we have Amazon's Neptune database. All of those databases can do labeled property graphs, and they are an RDF database. They could comply with RDF star, and so if I want to designate that Jack likes Jill, and I want to put how much Jack likes Jill, I can designate that in an RDF database. If I want to designate when Jack started liking Jill, I can do that as well. Also, additional properties on Jack, additional properties on Jill. All of those available are right now in an RDF database. I recently wrote an article, and it was published in Medium, on the 3 myths of graph databases. This is myth number 3. RDF star is here, it's ready to go, and you can use it as part of a modern RDF database. The nice thing is, imagine now we have a marriage of label property graph and RDF. So, some of the things we're thinking about is, can I put Cypher and Sparkle on the same database? If I have people who like to run Sparkle and people who like to use Cypher, I can have them access the same database through a different port and do their analytics. So it's here, it's ready to go, and I think it's a nice addition. In addition to that, if you think about it, properties with property graphs, it was kind of hard in the past to do inferencing. But now we have RDF with property graph, and you can do inferencing on that platform. So I think it's really powerful, and it's the way the market's going to go, in my opinion.
You may as well keep it, because the next question is a kind of natural evolution of this one. So you already kind of touched upon it when you talked about query languages. So these are like, it was also mentioned in another talk today. So these are like the key elements for building a database. So you have a data model, and obviously you need a query language. So we have a number of those around. You mentioned Sparkle, Cypher, Gremlin. So what's your take? You already kind of touched upon it.
I did already touch on it. I think you should use whatever language you prefer to use, and if you prefer to use Sparkle and follow the same semantic, sort of endpoint, Sparkle endpoint syntax, you can follow that syntax. If you grew up and you know Cypher, you should be able to use that as well. And so that's what we're building out, is this additional capability around that. Let's face it; those are declarative languages, right? And declarative languages are great. There's Gremlin, which is a procedural language. There's things like Python, which are also very interesting languages to add on to this. Once you start to add on additional languages like that, there's additional power that you bring. So I know several people in this conference have touched upon machine learning and AI. And can you imagine, having a graph and being able to do Python on a graph, and then having that AI and machine learning functions? So that's kind of the vision that we see, is the ability to use multiple languages on top of the graph, so you can do what you need to do. Yeah.
Well, you did mention Gremlin, and Gremlin being a procedural language, and I also used to think that, but then I know that he thinks otherwise. So.
Well, it's a little bit of both, from what I understand, right? Yeah.
It is a little bit of both. I mentioned a predecessor of Gremlin, which was Ripple, which is a functional programming language, and Gremlin still has a lot of that feel of composing functional pipelines together, and it's been really gratifying to see how popular Gremlin has become. Just like it's been gratifying to see property graphs become as popular as they are. Both of them still have some flaws. Neither one is perfect, and there's still some things we can do to make property graphs better, and also to make Gremlin better. I think in Tinkerbot 4 we're probably going to have monadic encapsulation of side effects and errors, which is going to bring Gremlin a bit closer to the functional paradigm. But there's never going to be one graph query language to rule them all. It's never going to be all Gremlin. The point you just made, we'll still be using Sparkle. We'll still be using Cypher. Sparkle was a little limiting in the early days. Sparkle 1.0 didn't support any kind of path language, but Sparkle 1.1 has support for regex paths, basically, which it doesn't have quite the power of, say, a Gremlin traversal, which is literally a Turing complete language. But I think all these languages are going to have their place. So it's not a fight to the death between these things.
I'd add, George, in terms of the goal, right? How does graph get wider adoption? I think it's when we stop talking about these kinds of things, right? That is when we'll know that you kind of got there. I mean, I've just been, trying to hire data scientists, trying to hire data engineers, and there's, nobody says, hey, I've got Gremlin, I've got Sparkle. It's just, I get lots of hate mail for saying this, but it's not as widely understood across the industry as it needs to be. And I think maybe that's a problem that we have in the industry that we need to try and change. And while we're trying to train everybody on like 5 or 6 competing languages, it's always going to be a problem. I think the key thing is, you just mentioned, right, if you can interface with these with Python, if you can interface these with those languages that are becoming the kind of de facto standards in the machine learning world, then I think we have more chance. So I think that piece of work to get broader adoption is creating those interfaces, whether that's layers of abstraction on top of the core systems. Somebody still has to do that core work, right? But I think for that broader adoption, I don't think you're going to get millions and millions of Gremlin developers out there. I think it's going to be running the core systems, and then you're going to have abstractions on top.
Yeah, actually, you kind of touched upon standardization, and we should mention that there is an ongoing effort to standardize graph query languages, and that's kind of always been a pain point. And actually, so for us, it's kind of easy to talk about all these different variants because, well, we're kind of familiar with them. But for someone who's approaching this space for the first time, I can totally get how they get overwhelmed. Like, which query language should I choose? It sounds like a very reasonable question to ask. So that's what we're trying to answer, I guess. So kind of wrapping up here, and I guess your point is quite clear. It shouldn't be about the query language, but about the way to access it. So, on a kind of closing note, where do you think what's the future for graph databases?
I think I'm supposed to skip this one. Yeah, you just said time. Be happy to answer it, but go ahead. Thanks.
Okay. Well, I think there are a few things. I tried to make the point this morning. I don't think you've seen the last of hypergraph databases or hypergraph data models. That's not necessarily the future. Predicting the future is notoriously hard. But I believe combining graph processing with stream processing is going to become important in the next few years. And we're working on a graph streaming solution at Uber, and there are others, particularly in the semantic web domain, not so much in the property graphs domain yet, but I think that's going to change. That's about all I have to say.
I think that as graph databases are developing and enhancing and improving, right, and you see releases from all the vendors, all the time, the rest of the world isn't standing still either. And I think you look at what the major cloud providers are doing, a lot of the capabilities they're making available, the speed and performance of those systems. In several of our projects, we've kind of given up waiting for the analytics capabilities within some of the graph engines, and we've gone, okay, we're going to be using Spark to do that because we can distribute it, and maybe it's not very elegant, but we just have to do it and fight that battle. And we've done that in a number of different use cases because we can't get the performance that we need for the business use case. And I think within the graph community, as things develop, potentially, we have to continue to stay in touch with those other developments, right? Because, we try and get these languages sorted out. We try and get the performance of the analytics layer and the search layer and everything else in one place. And I wonder if that will be the answer, right? I mean, that's what Cambridge Semantics would like us to believe, and others. But I think practically, you've got a data mart, and you've got your kind of calculation layer, and you have your distribution layer. And we often find that it's still that right tool for the job. And I do wonder if we're trying sometimes to get everything fitting into the graph. And that actually causes a lot of problems because we're trying to do too much.
Okay, thanks. And this is the part where I turn into a host again and ask you if any of you have questions.
So based on the title, graph databases will take over in 2020. What makes now different? Because I've heard that for, the past 3 decades. We had object databases, then RDF databases, and then the next version. Why is it different now?
Hard to say why, but it is, isn't it? I mean, yeah, there was a big push on RDF and linked data, and that was kind of a little bit top-down, I felt. I am still a big enthusiast of linked data. We're building linked data like things in Uber, and I would like to see more kind of integration of data sets across company silos as well. And linked data kind of paved the way for that. So I think RDF is still alive and well. Linked data is actually being used in business, particularly in Europe. But I think RDF did succeed. There's something about graph databases that has really caught on, and it's hard to define exactly what that is. You heard my opinions. I think it has a bit to do with the naturalness of the data model with respect to how we think about things. But so not really an answer to the question, just a little context, I guess.
Well, let me try this. So we evolve with our analytics, right? We evolve from having a DB2 mainframe way back in the day to data warehouse analytics and so on. The analytics that you guys are being asked for right now are more complicated and more complex than ever. And so just having a data warehouse or having some of the older technologies, it's not going to cut it anymore. And that's why this connected analysis, PageRank, shortest path, all of these things need to be part of your bag of tools that you can bring out and bring to the organization. That way your organization could be more competitive. And I think it's a simple evolution of where we're going for the next generation.
I think the thing I see driving it is understanding that to do the more advanced analytics, you need to treat your data differently.
Yeah.
And you need to add semantics into your data, and you need to think of the provenance and the history, and particularly in the finance space, like where every single piece of data came from and where's it going to and what's it being used in, and graphs are a great way for modeling that. And I think there's a drive there that having that conscious core modeling is one of the things that's driving graph adoption that we see in finance.
Any other questions?
So, on the subject of RDF star, one of the things that I noted about it was the edges are all anonymous. Do you think that is an issue for replicating the full functionality of a property graph?
Go ahead. I'm not entirely sure I understood the question. So, edges are anonymous. You mean by that?
So the edge of a property graph is defined by the triple that it comprises. So that means you can't have two triples with the same predicate between the same pair of nodes.
Well, they're not predicates. They're labels in property graphs, right? And you can have two edges with the same label.
Yeah,
I think I'm still not getting it.
You
And-
can't in RDF star.
Well, in RDF star, it's still an RDF triple, right? It's a subject, a predicate, and an object, and two triples can share a predicate.
Maybe we'll catch up later.
Sure.
Yeah, that's a deep dive topic.
Yeah.
There's, let me just mention one thing on that. So, there's two schools of thought under the new RDF spec. One is that we, completely support reification, which has blank nodes, and it's sort of this mathematically pure but really difficult way to represent properties. And the other is to act more like a property graph, like Neo4j and the current property graphs that are out there. And so I think where the market is going is to act more like Neo4j and the other property graphs. So we can get into what you're talking about, but maybe you're talking about the first example, reification, which is, hopefully that doesn't take hold.
And I can add a little bit more to that in terms of RDF star being a little bit more expressive than property graphs. In property graphs, an edge can have a property, but that's just a data type value. In RDF star, you can actually have a statement from a statement to a resource, which I believe can even be another statement. So a few of those things I showed in the kindergartner's graph can be expressed in RDF star that can't be expressed in property graphs right now, in typical property graphs.
Okay. Okay, yeah. You know, the moment I hear the word verification, I know we have to wrap up. Okay, thank you.
Sorry about that.